In this video, we will continue to talk about those arithmetic instructions, how they will affect the status flag. So here we can see this a complete concept map. We know we have the arithmetic logic unit in the CPU. So when we have arithmetic logic units, when they have any instruction we need to work, we will using to work the arithmetic or bitwise operation. So those operations after we execute, they will affect the status flag. And sometimes the status flag, including the zero flag, carry flag, overflow flag, we have few status flag. Those status flag will use by the conditional jump. So that's what we will talk about in next week at the second half of the chapter 4. So that will cause the branching logic we can do. If that's correct, we do something. If not, we do something. So that's the whole concept map. Earlier, we only focused on how to using those instructions. So we have a data transfer. So those arithmetic or bitwise operation will affect the status flag. So that's in this video, we will focus on what kind of instruction will affect the status flag and how those status flag we can see the result is. So the flag affected by the arithmetic instruction. In the arithmetic logic unit, you have a number of status flag that reflect the outcome of the arithmetic or bitwise operation. So they were based on the result. So those instructions, remember, sometimes we have destination operand or source operand. So of course, after we done the instruction, they will update the destination operand value. So that's why the status flag will according to the value or the contents of the destination operand. So they will do the corresponding response. For example, zero flag. If your result in the destination operand is 0, so the 0 flag will be set. Then, like the sign flag. So destination operand, we will treat them no matter this destination operand, how we use that. But if we consider they are signed integer, the most significant bit will be using for the sign bit. So that's why the sign flag will be set when the destination operand is negative. On the other hand, that means your sign bit is set. So the sign flag is set. So those things you can see, they are all according to your destination operand result. Okay, then we have the carry flag and overflow flag. So the carry flag actually is set when the unsigned value is out of range. So that's including when you add, you will add and carry out to the next bit, or you need to borrow from. So for the sign value, if they are out of range, we will have overflow flag is set. So in this video, we will focus on these 4 status flag. We will see all the instructions we introduced earlier. We talk about move. We talk about increment, decrement. We talk about neg, exchange, and add and sub. So those instructions, they possibly will affect some status flag. But before we see the example, here we just want to summarize some important instruction. The first thing, move instruction will never affect any status flag. The reason is we only move the source value to the destination operand. So they didn't really do any calculation. So the move instruction won't affect any flags. Then we have increment and decrement. Right, you have increment and decrement. You will increment the operand by 1 to update the data, or minus 1 from the operand and update the data. So those instructions, yeah, they possibly will affect 0 flag, sign flag. But the only thing is, carry flag, even we know increment, decrement, we kind of is doing the +1 or -1. But one thing is, we are not really doing any calculation. We just decrement the bit. So they will update the flag for the 0 flag, sign flag. but the increment decrement won't affect the carry flag. So here we only say carry flag, but actually they won't affect the overflow flag either, because increment decrement not really do the addition or subtraction, because we only decrement or increment by 1. So they won't affect the carry flag or the overflow flag. So the last one, neck. So the neck actually means we want to change the sign. But the next instruction to change the sign, actually they are not really just reverse the sign bit. Instead, the next instruction, if they work on any non-zero operand, they always set the carry flag. Okay, we see why. So here actually is the neck, how they work. Because we talk about the neck is from the decimal point of view. We just change the sign. If they are negative 128, I change to positive 128. But that is from the decimal point of view, from the human eyes. In the computer world, when we really do the neck, we are not really just reverse the sign bit. Instead, the neck actually make the processor implement neck using the subtraction. So that's why you see when we say neck, that means what? From 0, the opposite sign, they will be the same distance. So that's why when we do the neck, actually they perform subtraction. They subtract the same operand from 0. So that's why you can see your sign kind of like reverse, but they actually doing the subtraction. So since the neck doing the subtraction from 0, so that's why earlier we say, when you do the neck instruction to any non-zero operand, so you always will set the carry flag, because they need to always borrow from the 0. So that's why they will set the carry flag. But you see, if the 0 subtract from 0, then they just 0. So that's why they don't set any carry flag, or they don't set any carry flag. So that's what we see the example again for the neck. We have the byte B. We have the byte array B. We have 1 and 0. So then we have sign byte is negative 128. So then when you do the neck val B, so that's 1, right? So even you feel like you just changed the sign, but actually they subtract from 0. So after your neck B perform, your 1 become negative 1. So that's why not only carry flag is set, then you see because they become negative 1, right? So then your sign bit will also be set. But because your value B is byte, is unsigned, so only the carry flag is set. Overflow flag is clear. So continue when we work on the val B plus 1, so then they will be work on the 0. So when you neck 0, because they are the 0 value, so that's why carry flag won't be set. So that's why here you have carry flag and overflow flag, they both are clear. So then you see the next one, when you have your signed byte, you are working on the negative number. Okay, so that's why when you neck negative 128, they become positive 128. So then this one is not only the carry flag is set, but also the overflow flag is set, because during the sign bit, negative 128, actually we don't have negative 120, negative 128 become positive 128, right? But sign byte is only between 127 to the negative 128. So if you have positive 128, they are overflow. So then actually they become 0. So that's the neck instruction, how they affect our flag. So here, just remember that's some special instruction, how they affect specific flag. So later now, we will talk about add instruction and sub instruction, how they will affect each flag. So the first thing, let's see the 0 flag. So the 0 flag is set when the result of an operation produces 0 in the destination operand. So that's why you can see here, when you move 1 to CX, move don't update any status flag. So then you have sub cx from 1 from cx. So 1 minus 1 becomes 0. So that's why your 0 flag will be set because the cx equal to 0. So continue, you have your ax equal to fff, right? So then we can increment the ax. So that's why you see fff. When you increment by 1, they will become 0. Even they carry out by 1, but you only have 2 bytes, so they just become 0. So this one, the same thing, 0 flag is set. And also you can see even earlier we say you kind of like carry over 1, right? But increment and the decrement, they don't affect the carry flag. So even you feel like they did kind of carry over 1, but they don't do that. So that's why here the 0 flag is set. And if we want to write, continue the CF, the C carry flag, the CF is clear. So then continue, right? So you have your AX become 0. So you increment by 1, AX become 1. Then 0 flag become clear. So that's the 0 flag. So remember, increment or decrement, we don't update the carry flag. So continue, we see the small example about the sign flag. The sign flag is set when the destination operand is negative. So kind of they're using the sign bit. The flag is clear when the destination is positive. So then when we do the move on CX with 0, so move don't change any status flag. So then when you sub CX with 1, so that's why 0 minus 1 not enough, right? So we need to borrow. So that's why after you borrow become -1. So then your sign flag become 1. Your sign flag become 1. Also your carry flag also being set, because here is you do the unsigned integer subtract. So then they are overflow, so they will be set for the carry flag. So then after they become -1, right? So you plus 2, so become 1. So CX become 1, so sign flag actually become 0. They didn't change anything. So if we want to know, right, since they just using the -1 plus 2, the carry flag is clear as well. So basically the sign flag is just a copy of the destination's highest bit. So you can see here the other example, you have AL equal to 0. So you sub become this. Okay, so this one actually is the -1, but then they just copy the most significant bit from your sign bit. Then we set the carry flag. The sign flag. So that's how they look like.